troubleshooting networks. So in this lesson, we're going to talk about troubleshooting our wired and our wired networks. So when we troubleshoot our networks, we have to understand the common symptoms for issues, and we have to understand the proper software or tools that we use to fix these issues. So the first one we're going to talk about is no connectivity. If you have a loss of connectivity, this can occur for many reasons. One is that your network cable is broken or disconnected from the workstation, switch, the patch panel, or even the wall jack. This can happen because users abuse our network equipment. Take a look at that network cable up there on the board. That is a real network cable that I've seen in the field. People have run over it, they have melted it, and they still wonder why it doesn't work. This would be the reason. Workstations have not received a proper DHCP address. If you're using DHCP to configure your IP addresses and it doesn't pull one, you're going to get an IP address to not be connected to the network. If your workstation is not properly configured for a static IP, you're using static configuration but you didn't give it an IP, a subnet mask, a gateway, and a DNS server, that can cause issues. Always be careful looking at those static IPs, because if somebody puts just one number in wrong in, say, the gateway or the DNS server, you're not going to be able to make a connection. So make sure you take a look at that. Network switch ports have been turned off. So our switch ports on the switch can actually be turned off electronically. So even though you see a wall jack, it doesn't necessarily mean that it's a live wall jack. And so you have to go back to the switch and verify it's on or off. And then incorrect power management settings. We can have power management settings that actually put the network jacks to sleep, making them so they're no longer usable, or if we're using something like an IP phone that requires power over Ethernet and we're not providing that power over Ethernet over the cable, that would cause us to have a device that's not going to connect either. So these are all just some issues you got to worry about with loss of connectivity. The next one we mentioned earlier is IPPA, automatic private IP addressing. So if you're using DHCP, it tries to pull a DHCP address. If it doesn't get one within a given period of time, it just picks one in the IPPA range of 169.254.something.something. If you have one of these addresses, it's not routable over the internet. It's not routable inside your local area network either. And this makes it so that your computer is unable to obtain an IP address from the DHCP server, and you won't be able to make an outside connection. So anytime you see this 169.254.something.something, what I want you to think about is you need to release the IP. To do that, you go to ipconfig/release. And then once you've released it, you're going to have no IP. Then you're going to do ipconfig/renew, saying give me a new IP by renewing your condition. Right? ipconfig/release, ipconfig/renew. Just renew without happens. So if you try doing renew without releasing the IP first, what's going to happen? It's going to try to renew the IP you already have. So when you get a DHCP lease, it may only be for 3 days. If you do ipconfig/renew, it's just going to re-up that lease and give you another 3-day lease from the time you're currently at. So by when you have an IPPA address, if you renew it, you're just saying, I'm going to keep it longer, which doesn't really do you much good. So you want to release this first, zero out your IP, and then renew, which says go back to the DHCP server, give me a new address. Okay? Good question. Limited connectivity. So limited connectivity means that the computer is connected to the network, but it's unable to connect to the internet. So I have local area network connection, but I can't make it out to the distant end. This can happen if you receive an IPPA address due to a non-responsive DHCP server like we just talked about. It will release and renew the IP. It's also caused by a computer that's unable to obtain a proper IP address or configuration from the DHCP server. Maybe it can't make its way past the gateway, your router, or your router may have lost its connection to the internet. And so your computer, which goes through the router to get out to the internet, can't make it out because the router lost its way. And this can be experienced when you have that loss of connection to the internet. Several ways to check this. Like I said, what you'll want to do is ping a distant end first, something like 8.8.8.8, which is a Google server. If you can get a good response from that, that means your connection to the internet is good. If you can't get a response from that, try pinging your gateway. If your gateway responds, then you know the problem exists between your gateway and the internet. Local connectivity. Local connectivity means the computer is connected to the network, but can only access the local host because it failed to receive an IP address. This is often caused by the computer being unable to obtain a proper IP address from the DHCP server, very similar to like what you get with an IPPA address. In this case, it was so bad, you didn't even give yourself an IPPA address. It just completely gave up. and it's only accessing the local host meaning your one machine. Okay? So this means it's a really bad condition. In this case, what you want to do is disconnect, try reconnecting, see if you can pick up a new IP address. Intermittent connectivity. Rarely this will occur on a wired network, but it can occur if your network cable is loose or damaged. Intermittent connectivity means sometimes it works, sometimes it doesn't. This can often be caused with EMI. So for instance, if I have a cable running across the floor, past a big motor, and every time the motor turns on in the factory, I lose my network because the motor creates EMI. So that would be a good example of that. Or it could be that your infrastructure is starting to fail. Maybe you have some rats in the attic, they're starting to chew through your cables, right? If they chew through a copper cable, they don't chew all the way through. Maybe sometimes it's connected and sometimes it's pulling apart and not connected. This can cause an issue for you. To correct it, you want to replace those old network cables with known good network cables. Verify the cables are properly run. Keep them away from fluorescent lights to keep EMI away and other EMI sources such as motors. And you want to verify all your infrastructure is working properly. IP conflicts. IP conflicts occur when two network devices are both assigned the same IP address. So, if I'm using static IPs and I gave Nick and Joe's computers both 192.168.1.2, what's going to happen is when they get on the network, you're going to see a message like this. One of their computers, the one that gets on second, is going to go, I've detected that there is an IP address conflict with another system, because we're both using the same thing. So the hard part about this is if you have a large network, tracking down where the other computer is that has that IP address as well. Again, if you're using DHCP, this will rarely come up. If you're using static, this becomes a big issue because you have to manage your static IPs. Slow network speeds. So what are some causes of getting slow network speeds? Such as a 7.2 kilobit per second download speed. That's horrible. That's worse than dial-up, right? Damaged cables, connectors, hubs, and switches. That can cause problems for you. If you're using hubs instead of switches, it's going to decrease your connections. So if I have 50 people all connected to a hub, that means I'm going to have 1/5 of the connection for each person, or 1/50th of the connection for each person. Very, very slow. If we connect high-speed network cards to low-speed infrastructure, so let's say I'm paying for 100 megabits for service, 100 megabits per second of service from Verizon Fios, but my hub or switch that I'm using is only a 10 megabit switch. Guess how fast I'm going to go? 10 megabits per second, right? So you want to make sure you're using the proper speed throughout the entire network. Also, if you have EMI or radio frequency interference, this can cause issues for your network cables, having multiple retransmissions and slowing down your network speeds. What are some of the solutions? We can correct this by verifying our cables and connectors aren't dirty, dry, brittle, or cracked, because that can cause interference for us. We can upgrade our infrastructure so we could take out those old 10 megabit per second switches and put in new 100 megabit per second switches. And we can verify that RFI and EMI is not affecting the network by doing a wireless survey. And I'll show you later what a wireless survey looks like to give you an idea of that. Cable tester, we talked about this in Tools of the Trade. It tests the conductors in the Ethernet cable, verifying that each one of those pins, all 8 pins, have a full continuity and there's no breaks in that wire. Okay? Verifies the pin out to the connectors as well, and they're very, very useful. I'll bring in a cable tester tomorrow as well for our lab time to see what you guys can get used to playing with some of those as well. Loopback plug, we talked about this in the Tools of the Trade as well. It connects our transmit to our receive pins or fibers, and allows us to test our networked interfaces using diagnostic software. It verifies that the cards are sending and receiving properly. Punchdown tool, again, we use this to terminate wires on a punchdown block without stripping off the insulation. Again, if we have a bad wire running from the jack through the ceiling to the punchdown panel, we may have to rerun that wire and repunch it down all the different ends. Toner probe. This allows us to find a cable if we have an undocumented network. So we can put the generator on one port and use the probe to find that by using a beeping sound, and it beeps louder and higher pitched as we find that device. Again, tomorrow for our lab, I'll bring that in and we'll play with that. Wire strippers are used to strip off the insulation of the cables or wires. Like we said before, we use this when we're creating cables of non-standard length or getting it ready to be put on a punch-down block. A crimper, it allows us to put on the end, the plastic end of the connector. Again, if you have a cable and the end has been damaged or destroyed, you can cut it off with a crimper right? There's a blade there on the inside handle, and then we can strip it using the wire stripper and remake the cable. And that way we can fix that problem. That's why we're talking about these tools again, because in networks, these same tools are the ones we're going to use to fix a lot of our infrastructure problems. From a software perspective, we can use ping. Ping is built into Microsoft. It's built into the command prompt. It's an an external tool. And what we're going to do is we're going to check IP connectivity between two network devices. For example, if I want to see if Google is up and running, I can do ping google.com, and I will receive back 4 pings from Google, and it will tell me how long it took to get there. In this example, it took 10, 13, 14, and 14 milliseconds, okay? That tells me I sent out four packets, and I received those 4 packets back, okay? If I do tack in, like ping tacked in up there, that says I want to do a certain number. In this case, I want to do 5 pings, or I could do 10 pings or 50 pings. If I use a -6, that says use IPv6 as my method of getting there and back. So ping-6 google.com will get me out to Google and back using IPv6 instead of IPv4. For the exam on A+, you really only need to know the fact that ping is going to go out and back, okay? And just the basic ping and the server you're trying to get to, or ping and the IP you're trying to get to. Traceroute, what it does is it's actually going to trace out the path between your device, the source, and the destination, showing every router it hits along the way. So if I go, in this case, I'm trying to do a trace route to this IP address, it's going to go the first place it didn't know, which was the guy's home router, this 192.168.111.1. And then it went out to the next router. The next one didn't talk, that's why it says request timeout. And then it went to this 68.87.207.33 address. And then you could see it went out through Comcast Seattle, went out through Comcast all the way down to Sacramento, Portland, San Jose, until it finally got to where he was trying to get to, which was Akamai Technologies. Okay, it tells you every single hop along the way. If you think about it, like if you flew a plane from here to Los Angeles, you're not getting on a one-way trip, right? Or one plane trip. You might go from here to New York, New York to Chicago, Chicago to Seattle, Seattle to Los Angeles, right? And this tells you every stop you made along the way. That's what this is doing with the way the data is traveling through the network. The use of this is if I try to go to google.com, for instance, and I can't get there, but I can get to my router, maybe it's something between me and Google and I got to figure out where that break is. Now, as a home user, we're not going to worry about that. We're either up or we're down. But if you're working in a network and you have many routers and switches throughout your network, as you're trying to figure out where the break in the connection is, it may be that this floor of the building isn't working, but the other floors are. Well, maybe we need to figure out what switches is serving this floor, which router. This can help us do that. So it does that by doing a series of pings all the way out for you. ipconfig. So I talked about this before when we get an IP address, right? If I type in ipconfig, I'll get the parameters for a particular Windows machine. If you do ipconfig/all, like I did here in the diagram, you'll see that we get a lot of information. We get the physical address, the MAC address. In this case, it is 000C2931FA14. Okay, that's our MAC address. I get the domain that it's on, local domain. I get the description of what kind of card I'm using. I get my IP address. And the fact that mine says preferred, you can see that here, tells me that this was a DHCP address. There's my subnet mask. There's that lease I was talking about. In my case, the lease was obtained at 6:32, and it's going to expire at 7:02 the same day. So they're only using 30-minute leases. Here's your default gateway. That's the router. In this case, the .2, which is your default gateway. Your DHCP server address. In my case, it was the .254 was a server there. And you can see the fact that it is using DHCP. DHCP enabled, yes, right there. Guys, you get a lot of information from using the ipconfig. Now, if you need to get rid of an address, you're going to do ipconfig/release. That releases the DHCP IP you pulled. Then you're going to do ipconfig/renew. That will pull up a new IP address for you. If you're having issues where you can't get to certain network devices, you may want to flush your DNS cache. You can do that by doing ipconfig/flush DNS. When we get into our labs, when we start working on simulations, I'll show you one where you need to do something like that. Because we can't get from one network, we changed our IP numbers, and now we can't get the names to resolve. We need to flush out that cache so that it'll work. And so we would do ipconfig/renew, ipconfig/renew, ipconfig/release, ipconfig/renew, and then ipconfig/flush DNS. 3 separate commands. And again, we'll play with those tomorrow when we start doing some more labs in our troubleshooting of our networks. Netstat. Netstat displays information about IP connections on a PC. You can view information about current sessions, including source and destination IP addresses and port numbers. So if you do something like netstat tac an tac p TCP, it's going to show you all the active TCP connections that the computer has and what ports they're on. So in my case, you can see I have port 135, 445, and all these other high number ports. 135 and 445 is Windows file sharing. That's NetBIOS. We talked about that when we did our port numbers, right? If I had an FTP connection, I might see that showing up as port 21. By an SMTP connection, it may be port 25, right? And you would see that here. The local address being 0000 means my local machine. And you'll see the foreign address that it connects to might be somebody else's IP. If you think you have a malware remote access tool, you can run something like this to see the connection from your computer to the bad guy's computer. You start seeing IPs over here that you're not familiar with, you can start doing research of why is that connection there. That's one of the uses of this. NBTstat. NBTstat, it displays NetBIOS information about IP-based networks. NetBIOS is what we use for Windows file sharing, okay? So in this case, I have a machine called 7 Simulator, and by doing NBTstat tac A, it said give me the name for that IP address. And that name was 7 Simulator. That was the workstation's name. Could just as easily be called Jason's PC, right? And it will also give me the MAC address, and if they're in a domain or a workgroup. In this case, they're the workgroup. Net is a command that has a ton of uses. The most basic one that we're going to talk about here is net use. And net use allows me to connect to a shared drive. So I'm going to do net use, the server or computer name, and then the drive you want to connect to. So in this case, I want to connect to computer name /C drive. So mine gets net use /7 simulator /C $, and that tells me the C drive. So now I have mapped to that particular C drive, and I can access files on that computer remotely. Okay, NetView will show me all the other computers that are on my current network that I've made connections to as well. But NetUse is the one that we'll see most often. And again, you're going to use that //server /share in that format that I showed you up here. Troubleshooting wireless networks. So Renee has a couple of troubleshooting things for our wireless networks here. Wireless networks have all the same problems we talked about with wired networks, except that instead of using cables, we're using radio frequency, okay? So we've got to worry about radio frequency issues. We're still going to have no connectivity issues, but some of those issues might be caused by things like the wireless card not working properly. If the wireless card isn't working or the antenna isn't working, we're not going to be able to get a signal out. You may be in an area where there's jamming going on or interference going on, or you may even have a weak signal. Maybe the wireless access point is 100 feet down the hallway. I'm not going to have a strong signal. That may cause a no connectivity for me. Intermittent connectivity. Intermittent connectivity with wireless usually has to do with interference. If you have radio frequency interference, you have to start thinking about what frequency does this operate at. So if there's a lot of cordless phones around or gaming consoles or security devices, and you're running a wireless B or G network, you're probably going to have some interference because they all operate at the 2.4 gigahertz range. If you're running a wireless AN or AC network, you want to check for other devices that are operating in the 5 gigahertz range, because they could be causing an issue. Cordless phones operate at 2.4, they operate at 5.8, and they operate at 6 gigahertz. So the only one that's going to affect us is if we're running wireless B or G. If we're running AN or AC, we're the 5 gigahertz range, we're not going to be affected by those cordless phones. Slow wireless network speeds. One of the reasons we can have it is weak signals if we're too far from the access point. If there's too many users on the access point. Remember, access points act as hubs. They're going to divide the bandwidth up. If we're supporting mixed mode, so if I'm supporting mixed mode and it supports both B and G, B only operates at 11, G operates at 54. As soon as some user connects at B speed at 11, everyone now is going to operate at 11. So it's really going to drop your speeds down. The other thing is your radio frequency interference. If you have radio frequency interference, what's going to happen is your Wi-Fi is going to have to retransmit multiple times to get that data over. You're going to get slow speeds. What are some of our solutions? Find the interference and eliminate it. You can boost your signal strength if you have a weak signal. You can add more access points to cut out the collision domains and increase the amount of bandwidth for each user. And you can disable mix mode. Again, unless you have a reason to support all B devices, you probably don't want mix mode on a G access point. If you're supporting N and all your devices are N, don't use mix mode. It'll get you faster speeds by not using it. So wireless locator, this is what we call a wireless survey. It allows us to do a real-time discovery and analysis and mapping of wireless networks. And there's lots of tools out here. Here's just a screenshot from one that I've used before. Essentially, I take my laptop with a GPS receiver in it and a wireless antenna. And as I walk around, I can detect where the access points are and put a little icon where I'm getting the strongest signals and start determining where are the access points in the area. This is kind of like war driving, but it's war walking, right? I used to do this over one of the bases I worked on. We would drive around in a little golf cart and map out the network and what Wi-Fi signals we could find. Okay? And we can do this either from an analysis standpoint where we want to get those signals stronger so we have better usage, like we would on a college campus, or if you're in like a military environment, you may want to be eliminating those wireless signals to make sure they're not going outside your base, right? From a security standpoint. So both uses there. The last thing we have here is a simple question for you. A user calls the help desk and states that they are receiving an IP conflict error on their computer. A user on the company network uses DHCP. The technician verified the PC is using DHCP to obtain obtain the TCP IP settings. Which two commands would you issue to resolve the issue? So if we have a conflict and we need to get a new IP, what do you guys think we want to do? Release and renew. Exactly. ipconfig/release, ipconfig/renew.